Hello everyone again and welcome to a new video. In this case we are going to have a look to Unit 3, Services in ROS, the part 1 in this case. But before starting with services, let me congratulate you because you have already finished the topics unit, which, let me say you, it's one of the main things, the most important things in ROS. Because with topics you can almost achieve anything you want in ROS. So congratulations, because you have achieved a huge part of your learning process with ROS. Then you would say, okay, so if with topics I can do almost anything, why do I need to learn services? Well, that's because with topics, yeah, it's true, you can do almost anything, but in some cases it will be too cumbersome, too hard to achieve with topics, and services will make your life much more easier. Yeah, so that's why you need to learn about services. Then, yeah, let's start. So, what's a service? A service, as the name itself says, is basically a ROS program that provides a functionality to you. So you can call this ROS service in order to perform an action. For instance, you can call a ROS service that will move a robot performing a circle, for instance. So yeah, let's explain a simple example so that you can maybe have a clear idea. So for instance, let's have a look at a very simple example, which is this one, in order to differentiate between topics, services, and actions, because this may help you to understand what is a service and what is the difference between the service and topics. Yeah. So let's do this example. So for instance, imagine you have your own personal BB-8 robot. In this case, let's talk about a Kabuki robot, for instance, because it's the one you have just used in topics. So imagine you have a Kabuki robot. Then this Kabuki robot, as you have seen in the previous units, has a laser sensor. Then let's say it has also a face recognition system and a navigation system. Yeah, so the face recognition system is to recognize faces of people, and the navigation system, it is to move the robot, yeah, to navigate the robot. So this laser will publish its information, its readings, into a topic. Yeah, as you've seen in the previous unit, the laser readings, the laser data is published into a topic, and this is done like this because you need to have this data always available. Yes. In the previous chapter and the mini project, you had to constantly check this laser data in order to do one thing or do another. Yeah, so that's why you publish this data into a topic, because you need to have this data always available at any time. Yes, so that's why you use a topic for that. Then the face recognition system of our Kabuki robot will provide a service that recognizes a face. Then you can call that service whenever you want, and that service will tell you, well, will execute its internal program, its internal code, and will tell you if that face is of a man or of a woman, for instance. Yes? Then you will call that service, and that service will tell you, hey, I am recognizing a man, or I am recognizing a woman. And then with that data you have, you can do whatever you want. For instance, you can do a program which says hello man or hello woman, I don't know. Yeah, but the service is for that. So you have that service that provides that functionality of recognizing a face. Then you can call that service, and that service will tell you, hey, I am recognizing a man or I am recognizing a woman, for instance. Yes? Then actions. What is an action? Well, actions, you will see it in the next unit, but let's just make a very brief introduction. So when would you use action then? So you have the topics for constant information, for instance, the laser readings. You have a service that provides a functionality that you can call at any time, and it will give you a response. And finally, you have an action that, for instance, can, let's say it's the navigation system that will make the robot move. Yes? We'll make the robot perform a circle and stop at its initial point. Yeah? So the robot will, you will call that action, then the robot will start moving like this and will stop at its starting point. Yeah? But you would say, okay, but I can achieve that with a service as well, right? So I can create a service that when I call it, the robot will perform that movement and will stop. Yeah, that's right. You can do that with a service if you want. But what's the difference? With a service, you have to wait until the robot performs that functionality. So the functionality of that service is to perform a circle movement with the robot. Then when you call that service, you have to wait until that finishes in order to continue with your program. Yes? You have to wait until the service finishes. In an action, you don't have that limitation. So in an action, you can call the action to perform that movement, and meanwhile the robot is doing whatever it has to do, the movement in this case, you can keep doing other stuff. Yes? So you can keep, I don't know, you can keep taking photos of the environment. Yes? For instance. So that's the main difference, yeah, between services and actions. And that means that services are synchronous, while actions are asynchronous. Yes? So with services, when you call a service, you have to wait until the service finishes and gives you the response in order to continue with your program. Yes? In actions, you don't have to wait. You can perform other stuff while the action is taking place. Yeah? That's very important. All right, so yeah, let's start with services. So first of all, let's start with this example 3.1. So we are going to execute this command here. Yeah. Let me switch to another view. Maybe this one will be better. Yeah. Okay. So yeah, let's copy this command here, and let's copy it to the web shell. So ROS launch one of demo start demo.launch. So let's execute this command here. And as you can see, the robot starts moving, starts doing a movement, yeah, a motion in this case. All right, so what is going on here? Well, it's very simple. Okay, yeah. So what has just happened here? So basically, the launch file we have executed here. Yes, this start demo.launch file. What does is to launch two nodes. Yes. The first node is the ERI1 reproduce trajectory. We are going to have a deeper look to this launch file later, so don't worry. But yeah, this launch file launches two nodes. Let's say the first node starts the service, so makes the service available for anyone to call it. Yes? The first node does that. And the second node, what does is to perform calls to this service. Yeah? It's basically that. So within this launch file, we are first starting the service. You always need to start a service before you can call it, of course. And second, it is calling this service. In this case, this service what does is to perform a motion, as you have seen here with the WAM arm. Yes? Okay, so then, yeah, let's continue with example 3.2. So yeah, we need to leave this launch executed in order to proceed. All right, so the first command we are going to check is this ROS Service list command. So let's execute it in another web shell. And as you can see, this is like the ROS topic list you saw with topics, but for services. So this command, the ROS Service list, gives us a list with all the services that this simulation provides. Yes? As you can see, yeah? All these, so you can see some services from the camera, from Gazebo, from the simulator, here from the robot itself, yes, for the controllers, the joints, for the Kinect camera. Well, you have many services, as you can see. So with this ROS service list command, we get a list of all the available services. Yeah, remember, just like ROS topic list, but for services. Then, yeah, we have this ROS service info command. Yeah, so this is like the ROS topic info as well, but for a service. So by executing the ROS service info and the name of the service, we will get information about that service. Yeah, for instance, let's do it for this execute trajectory service, which is this one here. Yeah, this is the service we started with this launch file and the service which is being called in order to perform these motions. Yeah, so this is the execute trajectory service. So let's execute this command here and check some information about this service. There we are. Excellent. So as you can see, we have here some information. Yeah. The first is the node. So this is the name of the node which is providing this service. Yeah. In this case, the node which provides this execute trajectory service, it's named ERI1 reproduce trajectory. Yes. Then we have here the URI. Don't worry about this right now. And we have the type. So this is like the topics message, like the twist you saw, yes? This is the message that this service uses, which in this case it's this exec trash message, which is contained in the ERI1 reproduce trajectory package. Yeah? And we are going to have a look later at services messages because they are a little bit different than the messages that topics use. Yeah? But well, in any case, this type defines the message, the type of message that this service is using. And finally, we have this arg, which is the arguments, and is the arguments that this service takes as an input. So when you call a service, you usually will call it with an argument, which is some information that the service will use in order to perform its functionality. Yes? In this case, the argument is called file. Yes? Okay, for this case, for the case of the execute trajectory service, the argument, for instance, is the path where the motion that it's executing is defined. Yeah? So we have some motions defined in the files, and with this file with this file argument you are providing this motion to the service. So when you call the service, you will provide this motion in a file to the service that the service will get and will execute, like you are seeing here. Yes? Okay, so now let's go again to the launch file executed here. So where I told you before that it did two things. First it started a service, the execute trajectory service, and then it called it as well. So let's have a deeper look at this file in order to analyze it. So let's stop it for a moment and let's execute these commands here. There we are. All right. So ROS CD ERI1 demo, CD launch, and then you can do this cut in order to visualize the file. Oops, sorry. Okay, I think I have modified something here, which I didn't want. Okay, there we are. Yeah, so the name is it's cat start demo.launch. All right, yeah, so we can visualize it here. As you can see, this is the content of the launch file. We executed, yes. So yeah, it basically has two parts. The first one is this include here, which is including another launch file. Yes, you can see. So yes, inside this is the first time you see this, but this is a very common practice in ROS. You can include other launch files inside a launch file. Yes, and you do it like this with this include tag, and then you indicate the launch file you want to include into this launch file. So yeah, this launch file will be executed. With this include tag, it will search for this start service.launch and it will execute it. Yes, and this start service.launch file is the launch file that is starting the execute trajectory service. Yeah, as I told you before. So with this first launch file, what I'm doing is to start the service, to make it available for anyone to call it. Yes. Then later here you have the node tag that you've seen previously and you have been using. And here you are basically launching a node. You are starting a ROS program. Yes. And in this case, this ROS program what does is to call the service you have started here. Yes. So this program here is calling the service, and within the call it's giving this argument, and yeah, it's giving this file argument, and in order to execute that motion. Yeah, so yeah, you have it here explained. The first part is this include, which is including another launch file that starts the service, and then you have a basic node tag, which you already have seen previously. And yeah, well, in the type you can see that it doesn't have the .py extension. This is because it is a CPP executable file. Yeah, so you obviously within this course you will work with Python in ROS, but you can also work with CPP. And in this case, the program is in CPP because it doesn't have this Python extension. Yes, and yeah, this is the program that performs calls to the service you have started here. Yes. Then okay, yeah, let's see. Let's check how to call a service. In this case, with the command line. Later you will see how to call it with code, with Python code. But for now, let's see how to call a service. And this is done. Let's maximize for a moment this. This is done with the ROS Service call command. Yes. So you specify ROS Service call. Then you have to specify the name of the service you want to call, and then you do a double tap in order to auto-complete the structure of the message. Yeah. Let's see an example of this. So for instance, yeah, let's minimize this again. Yeah, so within the ROS service list we did previously, we have a service which is right here, which is gazebo delete model. Yeah. So for instance, this service what does is to delete a model that is in the simulation. Yeah. So let's call this service. Let's try to call this service. Then let's do it like we have seen here with the ROS service call. Then we will specify the name of the service, which in this case is gazebo delete model, and then we do a double tap and it autocompletes the structure of the message. Yes, this is the type we saw previously. This here, it is defined by this type, the type of the service. Yeah, so in this case, yes, and inside this type you define the argument, which in this case, the argument, the information you provide to the service is the name of the model you want to delete. Yes, so in the example we saw with the execute trajectory service, we provided the information of the path where the file containing the motion it was. Yes, in this case, what the information we provide, the argument we provide to the argument we provide to the service is the name of the model we want to delete. Yes, and this is defined in the service message. We will see this later, so don't worry if at this point you have some doubts. I'm sure that while we advance through the unit, everything will be clearer and everything will make more sense. Yeah. So yeah, let's come back here, and then let's provide a name to delete, a name of a model. In this case, the name of the model we're going to delete is cafe table. Yes. So, all right. Let's introduce here cafe table, which is the name of the table, of course. So by executing this command, this call to a service, to the gazebo delete model service, what should happen is that the table in the simulation is deleted, right? So okay, let's see what happens. Let's execute this command, and as you can see, yes, the table has been deleted in the simulation. Yeah, and here I have a success true and status message, successfully deleted model. Yeah, so this is the response that the service gives to me. It says, hey, I could successfully delete the model. Everything went okay. Okay, so yeah, you have seen that this works. So I have called this gazebo delete model service. I have provided as an argument the name of the model I want to delete, and the service has done his functionality, and when he finishes, he says, hey, any problem, everything went okay. I could delete the model. Yes, as you can see here. So excellent, yes. Yes, here you can see a command that you can execute if you want in order to check. Let's do it here. By executing this command, you can have a look here. Here, you can have a look at the names of the models that are in the simulation. So yeah, the cafe table, we have deleted it, so it doesn't appear anymore here, but you have the ground plane, the Kinect, which is this camera here. We have the ball 2, ball 1, which are these balls here, the red and the blue. Unit box 1, which is this box, this white box here, and the area 1, which is the robot itself, of course. So you can test if you want with other elements, but well, let's for now let's continue with notebook with explanation. And then, okay, so we have seen with this ROS service call command how to call a service from the command line. Yes, but how we do this with code, programmatically, with Python code in this case. Okay, so for that, let's do this demonstration here, which is to execute this code here. Yes? So let's execute this code here and pay attention to the simulation window to see what happens if anything happens. So yeah, I will come here, I will execute this piece of Python code, and oh, ball 1 deleted. So as you can see, the blue ball, which is called ball 1, has been deleted. Yeah, so it has happened something very similar from the thing we did with the ROS service call, but you executing this piece of Python code. And I even get also the success true and the status message here, like I got here, yeah? Okay, so let's have a look at this code to see what it contains. There we are. Excellent, yeah, so we are importing ROSBy as always, then we are importing also this delete model and delete model request messages from the gazebo messages package, the SRV directory. Yes, this is important, we are going to see it next. So here what we are doing is to import the service message we are going to use. You remember in the previous unit you had to do something very similar for importing the twist message or even the odometry message. Yes. So here you're doing the same but for a service message. Yes, the delete model and the delete model request messages. Okay. Then we are importing sys, the sys module, because we are going to use it. Then, as always, we start initiating a node. Yes. Then once the program starts, we have this wait for service function. What this does is to wait to check if this gazebo delete model service is available. Yeah. So if this service is not available, this won't be executed. Yes. In this case, as we have seen, the gazebo delete model was available. Yes. So then we can execute this code. Yes. This service is always available in this case. So with this function, ROSBy wait for service, we make sure that the service we want to call is up and running and ready to be called. Yes. Then here we create, let's say, a connection to the service. Yes. With this service proxy, ROSBy.service proxy, we create the connection with the service. Then we have to specify the name of the service, of course, the name of the service we want to connect to, and we specify as well the type of the message. Yeah, this is very similar to how you worked with topics, where you had to specify the name of the topic and the name of the message you are going to use for that topic, either if you were publishing or reading from that topic. Yeah. So yeah, you create the connection to the service and you specify the name of the service and the type of message that service uses. In this case, it's delete model. Then here you create an instance of this delete model request message. Yes. Then you specify the name of the model. We are specifying the name of the model here, which is bowl1. Yes. So here we specified the name, the model name here, as you could see. Yes. In the code, let's go here. In the code, we specify it like this. Yeah. So here in the kk variable, we created an instance of this delete model request message. Then here we access to the model name variable of this kk instance message, and we tell him to store the bowl1 value. Yes. Then finally, here what we are doing is to call the service, delete model service, which we define it here. We call the service passing the kk message, and we stored the response of the service in this result value. Yes, which was the response is this, of course. Then we print this result. As you could see here, the result is printed because of this print, of course. Yeah. So we call the service passing the message we want here with the argument of the model name, and we store the response of this service in the result value. Then finally we print this result in order to see if it went well, if it failed. Yes. Yeah, excellent. So yeah, this is the code. It's quite simple, I think. So yeah, let's continue. The next one is the example 3.6. So how to know the structure of the service message used by the service. Okay, so yeah, in this code here, we were using this delete model and delete model request. Yeah, with this delete model request, which is the message used to call the service, we created an instance here and we filled this message with the model name variable. Yeah, but how can we know which variables to access? How did we know that this message had a model name variable? Okay, so this is done with the ROS. Well, first of all, you have to execute this ROS service info in order to know the type of the message, of course, as we saw here. Well, let's do it again in this case. ROS service, wait a second, I'm going to clear this. Okay, there we are. So I'm going to execute a ROS service info of the gazebo. What I'm doing wrong? Okay, so okay, here we are. Yeah, I don't know what I was doing wrong. Okay, so yeah, we execute this ROS service info command specifying the name of the service, which in this case it's gazebo delete model, and this way we can know the type of message that the service uses. Yes, in this case it's the delete model message inside the gazebo messages package. Yes. Then now, in order to know information about this delete model message, we can execute this command here, the ROS service show. Yes, this is like the ROS message show. You use it in topics. Yeah. So okay, let's execute this command here. You have to specify the name of the package, which is gazebo messages, as you can see there, and delete model. Yeah, ROS service show gazebo messages delete model. Then by executing this command, you can get information about how this message is structured, how this message is defined. Yes. In this case, you can see that it is divided in two parts. Yes, this is a very important difference from topics. In topics, you just had one field, let's say one zone, in order to define your message. Here, the structure is divided by these three lines here. Yes, and this is very important because this is the structure of any service message. Yes, all service messages will be divided by these three lines. Yes, if you see any message which contains something here, then three lines, and then something down here, this will always mean that this is a service message. Yes. Then, as you can see here, yeah, this first part of the message is the request of the service. Here we define the request of the service. Yes, so how I will call the service. Yes, this part of the message is called the request. So it defines how I will call the service. Yes, in this case, when I call this gazebo delete model, yes, I define this model name, yes, which is this variable here, as you can see, and the same goes for the code, yeah. Before calling the service, I fill it in this model name variable, yeah. So I fill it in the request of the message before calling the service, yeah. And this request of the message in this case is defined by this model name variable, yeah, which stores the name of the model we want to delete. Yeah, so this is the first part of the message, the request of the message. Then the second part of the message, the part which is below these 3 lines, is the response of the message, yeah. So this part defines what will be the response of the service. In this case, we have 2 variables, a bool, which is called success, and a string, which is called status message. Yeah, and this is exactly this. Yeah, so when I call the service response gives me a response in this form with a success to true or false because it is a bool, and a status message variable which contains a string, which in this case is delete model, successfully deleted model. Yeah, so I have this success, which is a bool, and this status message, which is a string. Yes, the same goes here. When we used the ROS Service call, I also had this success and this status message. Yes, so this is very important here. Service messages have 2 parts. The first part is called the request, and it defines how you will call the service, what variables you will need to pass to this service when you call it. Yes, and the second part of the message is called the response, and it defines how the response how the service will respond to you when it finishes whatever it has to do. Yes, very important. Excellent. Yeah, so let's keep moving. Let's continue. Okay, yeah, we are basically at the end, and here you have an exercise. This exercise 3.1. Let's read it, but I will leave you alone in order to do it because I think you need to try to do it by yourself. So yeah, first of all, create a package in order to place all the future code. Okay, so you will create a package, you already know how to do that. Then you will create a launch file that has to start the execute trajectory service. Yes, as you saw, as you have learned, before you can call a service, you have to start it, obviously. Then you will have to create a launch file that starts the execute trajectory service. Yeah, which is the service that was started in the first demo you did at the beginning of the unit. Yes, so you will need to start as well this service in a launch file. Yeah, you can check this example 3.3 where it explains more or less how to launch it, so you can have a look if you want. Then you will need to get information of what type of message this service uses. Yes, you already saw this at the beginning of the unit as well. Using the ROS service info command, you can get information about this. And then yeah, you have to create a code like this one in the example 3.5. Yeah, so you will have to create a Python code and copy paste this code here. Yes, like it is. Then you will have to modify this code to, instead of calling this delete model, this gazebo delete model service, to call the execute trajectory service. Yes. So you will have to call this service. Of course, the type of message you set won't be debug model, will be another one. You have to check how it is, and obviously the argument won't be model name also. So you have to check what argument uses, and yeah, how to fill it, what do you need to put into that argument. And for that you can have a look here, because as you saw at the beginning of the unit when we were checking this execute trajectory service, the argument, let's have a look very quick here, ROS service info. Well, now it won't be, yeah, now, well, let's do it anyways, but now it will give me an error message, as you will see, unknown service. Yes. Why? Well, because this service now it's not running. It was running here when I executed this command. Now it is started. So now if I execute again this command, I will get the information, because now I have started the service. Yeah. So yeah, if you remember, the argument for this service was a path to a file that contains a motion to execute this motion that is performing this arm, this WAM arm, is defined inside this file. Yes. So the argument you need to pass to this service is the path to this file. Yeah. Then here you have a hint of how to do this, how you can achieve it. Yes. So yeah, at the end you will have to have a package with a launch file and a Python file. Yes. Then by launching this launch file, you will have to first start the execute trajectory service, and then call your Python file, which will call the execute trajectory service with code. Yeah, using Python code. So that's the exercise you have to do. Try to do it, and if you get very stuck, that you don't have any idea of what to do, you can have a look, if you want, at the solution to this exercise here. Yeah. So if you come here and you click to this link, you will be able to have a look at the solution, how to solve this exercise. But I really encourage you to try to solve it by yourself, because this is the way you will learn the most. Yes. So, well, yeah, that's it. I will leave you alone, and I will see you in the next part, which is ROS Services Part 2. So, goodbye.